In this video, I'm going to go over the rules for recognizing significant figures in other people's measurements. This is going to become important when we start doing calculations with other people's measurements, and then the calculator gives us like 15 digits we don't know what to do with. We'll know how many of those are significant figures that we need to keep, and then what needs to be rounded away. The first rule says that non-zero digits are always significant. So in my infographic over here, that means if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, a non-zero digit represented by a number sign, it's always a significant figure. And then zeros that are in between those are also significant figures. So in my infographic, if it's a smiley face, that's a zero, that's a significant figure. So in this little infographic, we have a number sign, which is 1 through 9, a 0, and then a 1 through 9. And since that zero is in between, it's a significant figure. I've got two examples for you to write down in your packet. The first one is 4.02, and it has three significant figures. Each one of those digits is a significant figure. The 4 and the 2 are not 0, and then the 0 is in between, so all three are sig figs. The next example is 5009. The rule says zeros plural between non-zero digits are significant figures. So it doesn't matter how many zeros are in between. That one's going to be 4 significant figures because the 5 and the 9 are not 0. So I'm going to give you a little bit of time. In your packet, I want you to make up an example, just any number, that make sure the only zeros you put are in between non-zero digits, and then do like I did, write how many significant figures that is. Then put this in your own words, because non-zero digits does not seem like a 15 or 16-year-old person's way of saying number 1 through 9. So pause the video, write these in, this also, and then hit play when you're ready. Here's rule number 2. This one talks about zeros in a different location. It calls them leading zeros, and they are not significant. So in my infographic, I've got 2 zeros. They are both frowny faces, which means they're not significant figures. They happen before any non-zero digit. So there's my number sign over on the right. Finally, after 2 zeros, we come up with a 1 through 9 where our significant figures would be. So the examples I have are 0.00402. That has 3 significant figures because just the last 3 are significant. Just the 4, the 2, and then because that 0 in between them is a rule number 1 0, it's a significant figure. Then 0.05009, same situation as the first one. The 5 and the 9 are significant figures. The 2 zeros in between, rule number 1, but those first 2 are not significant figures because they're just leading zeros. Basically, they are placeholders keeping those non-zero digits in the specific place, like in this one, it's in the hundredths place. So take a minute. Make up your own example. This time you can have 2 types of zeros if you like. Make sure you put leading zeros, and then if you want to put rule number 1, I call those sandwiched zeros, you can, and then indicate how many significant figures you made up. Then in this one, make up this in your own words. Maybe you don't call them leading zeros. Maybe you say zeros in the front. Maybe you say zeros before. Just pause the video, write these in, and then hit play. In rule number 3, they're talking about zeros in the only other location that's left. We've talked about in between, we've talked about on the left before anything. Now we're going to talk about zeros on the right that happen after all the other digits have occurred. So they call these zeros to the right of all non-zero digits, and they are only significant if a decimal point is shown somewhere in the number. So if you look in the box here, we have the first situation, there is no decimal point shown anywhere. So both of those zeros are frowny faces, meaning they are not significant figures. But in the bottom example, I have smiley face zeros, and there is a decimal point shown. It really doesn't matter where the decimal point is in the number. As long as you can see it, any zeros on the right are going to be significant figures. Now I have a ton of examples I'm going to show you. Only copy down 2. You only have room in your packet for 2. So after you've seen all 6 examples, then you can decide which one works for you. So here's 42,600. This is going to have 3 significant figures because just the 4, the 2, and the 6 are significant. There's no decimal point shown in the number, so those last 2 zeros are not significant figures. We assume that they're there because maybe they rounded to the hundreds place and just needed placeholders. But if I took those same exact digits and put them in a different number, 42.600, that's going to have 5 significant figures. I can see the decimal point, which makes the zeros on the right significant figures. That tells me maybe it came from a piece of equipment that had markings all the way out, and they were like, it is exactly on the 0.6 line. The number 200 just has one significant figure, and it's the 2 right there. We're assuming they're estimating. Yeah, there's about 200 people in this room. But if it's 200.00 and I see that decimal point in the number, then all 4 of these are significant figures. And again, I'm assuming that came from some equipment and it was exactly on the 200 line and it was not a little bit over or a little bit under. The number 0.02 has only one significant figure, and it's the 2, because the leading zeros are not significant. That's rule number 2. But if I take that same exact number and I put a 0 on the right, now that's a significant figure. Because I can see a decimal point in this number, 0 on the right is going to be a significant figure. So that's telling me that I wasn't estimating that it's 0.02. I'm really, really sure it's 0.02. So pick from that list 2 examples that you think really illustrate this rule for you. Then make up an example of your own. You can put all 3 kinds of zeros this time if you want, and then make sure you tell how many significant figures that is. Then put it in your own words. Pause the video, hit play when you're ready. The last rule is going to be the rule we use the most because it's about values that are written in scientific notation. And when you're looking at a number that's in scientific notation, the coefficient is all we care about. So in my little graphic here, this is all that we care about. We don't care about the 10, we don't care about the exponent. We're only going to look at the coefficient when we're determining significant figures. And rules 1, 2, and 3 apply to that coefficient. So here's my first example. This one is not so important for you to write down. So 4.3 times 10 to the third has 2 significant figures, just the 4.3. We don't care about the times 10 to the third. This example you should probably write down. This one, the coefficient, 5.09, has 3 sig figs because of rule number 1. The 0 in between, that's a significant figure. This last example is the most important to write down. 2.00 times 10 to the second has 3 significant figures. The coefficient is 2.00. And because of rule number 3, those zeros on the right are significant figures. If I had taken the same exact number, but I wrote it in standard form, it would be 200. Well, we learned in the previous rule, that's just one significant figure. So if you have 200 come up on your calculator as the calculated answer, but you have to have 3 significant figures, we would have to put this in scientific notation. That way rule number 3 lets that coefficient have 3 significant figures. So this is a super important one for you to write down. So now you're going to make up your own example, and you're going to put this in your own words. And this time you don't have to pause the video, you can just stop it because we're not going to cover rule number 5.